All right, hello everyone. I am Simran Mitharu and I'm here with my teammates from Team 5, Jenny Cunningham, Max Gervik, Haley Huang, Chris Danko, and Laura Sweeto. And today we'll be discussing our analysis of traffic conditions in Austin, Texas. So to start off, I'll give you a bit of a background about the data that we dealt with, specifically the context and understanding. Then we'll dive into the strategy and architecture, as well as the data and analysis and some of the visualizations that we came up with. And then we'll focus on a summary and some of the insights and challenges that we uncovered. So to give you a bit of an understanding of the data and the context, we chose to focus on the perspective of a company XYZ, which is a logistics firm based in Austin, Texas. And through our data analysis, we wanted to focus on three key questions, one of which is what time of the day and what day of the week has the lowest traffic or the highest speeds? Are there any roads where the traffic is low? And also for the drivers that are associated with company XYZ, are there any locations where these drivers should pay more attention to the roads? So our hope is that by addressing these specific questions in our analysis, we can help company XYZ improve overall efficiency and also ensure that drivers are safely operating vehicles. To give you a better understanding of the types of data that we were working with, we primarily focused on big data derived from two separate reports, one of which was traffic reports, and the other was from travel sensors and radar data. So our first data set focused on traffic data and included some measures and metrics such as speed and volume, which were captured by travel sensors. And our other data set focused on information that was specific about these sensors. So some of these measures included sensor location, jurisdiction, and also landmarks that were associated with each sensor. As we were going through and analyzing and making a first pass of our data, we found that several attributes weren't not necessarily needed in our analysis. And we also chose to filter out certain outliers. So for example, we saw some speeds were generally higher than others. And we also found that some records didn't necessarily contain an ID. So we filtered those out as well. We also conducted some data manipulation for certain fields. So specifically some of our time and date fields we had to manipulate a bit. And we also joined these two data sets using a primary key for the travel sensor data, which was KITS ID, and referenced it as a foreign key in the radar traffic counts data set, as you can see.
Yeah, so the overall goal for the data we utilize is to obtain insights from the traffic data specifically located in Austin, Texas. And for the organization, this can lead to insights and actionable strategy that can include increased delivery speed and efficiency, inform logistics sectors, address overall traffic efficiency for the organization. Some more details about this data is that the variables of interest include traffic speeds, volumes, day of the week, and time of the day, as well as directional information. This data is derived from traffic sensors, which is continuously collected in an unstructured form. Next, I'll get into a little bit more about the strategy and architecture. So for our strategy and architecture, we wanted to focus on the standard methodology that includes operational, reconciled, derived, and the analytics layer of the pipeline, as well as the enabling tools supporting these. In the operational layer, we wanted to ensure we were able to source our data from an underlying database. For this, we sourced our data from Microsoft SQL Server, which acts as an operational database. In the reconciled layer, we utilize Alteryx, which is a great and usable software that allows us to pull from that underlying operational database and perform data cleansing operations to create a data structure that has increased usability for that end business user of the organization. Within the derived layer, we wanted to make sure to transition that cleansed data into a data store or data warehouse. And for this, we utilize a separate Microsoft SQL server to host the cleansed data. Now, the business end user from here are able to connect to this data warehouse and obtain the information needed to perform their necessary analytics. For the analytics section specifically, we utilize Tableau, and this is a well-known and very capable software to perform various analytics and visualizations to generate those actionable business insights for the organization. Now I'll pass it off to Chris to talk a little bit more about the data transformations.
So here's just a little better picture of our pipeline, but I think it's important to mention here how large our data was. So the radar traffic counts table there you see, it was approximately 6.5 million rows to begin with. And after Alteryx, it ended up being right around the almost 5 million rows. So we had to be very careful with each and every operation that we performed in either Alteryx or Python, and then pulling it out of the first database and into the next, and then into Tableau as well. Go ahead, next slide, please. So the first step was bringing in this massive data. As you can see, so the top workflow here is the radar traffic counts. And so the first thing that we ran into was a data quality issue with our dates. And so if you'll jump back to slide number 4 real quick, we had this on the far left table, radar traffic counts. About the third column down is called read date. And so we initially wanted to rely on this read date. However, unfortunately, there was some obvious incorrect data in this, which was, for example, there was a 1970s, there was many 1970s date with like 0 hour and 0 minute. And so fortunately for us, we had we found it to be more accurate to build our own date using the day, month, year, hour, and minute function. Now we can jump back down to slide number 8. So we went ahead and built that date with the formula function and then converted it to a date and time. And then as Simran mentioned, we had some extra columns we didn't need. And then filtering out, so each speed record has an average speed of that 15-minute time block and an average volume of that for that 15-minute time block. However, there were some records that were not on this 0, 15, 30, or 45-minute time block. So we went ahead and filtered those out, and that actually solves a lot of problems for us with just problematic extra dates and null values and stuff like that. And so this is where we jump into the Python, which is this next filter. And so we filtered out speed records that were greater than 90 miles per hour. And if you go to the next slide real quick, I can explain a little bit better. So you can see the speed. We have a plot histogram of the speed, and we see that this is normally distributed with an extremely long tail to the right, which skewed the data quite a bit. And so after plotting the box and whisker plot, I went ahead and I tried to be conservative about the number. We tried to be conservative about the number that we used here, which was 90 miles an hour, which is give us a little bit of leeway. But you can go back to slide 8. And so that's that very top, filtering out outliers in speed records greater than 90 miles per hour. Then on the bottom workflow here, we brought in the travel sensor data. And so here we were only interested in location data. So the latitude, longitude, and the neighborhood, so northwest, central, where these specific radar guns were located. And then, there was additionally, back in slide 4, we don't need to go there, but there was many columns there that were not location based. There were lots of null values in that data table, and so we went ahead and deselected those, eliminated those, and then filtered out radar guns that did not have a KITS ID. Then we went ahead and joined based on that KITS ID using the primary key in travel sensor data and pulling in a foreign key KITS ID from the radar traffic sensor table. And yes, that concludes data transformation.
Okay, so after we transformed the data and went through the underlying architecture, then we moved into the visualizations with Tableau. Now, in order to get this data, we did connect through the Microsoft SQL Management Server. Instead of just connecting through a CSV file, we wanted to make it all connected throughout the entire project. So we did make that connection there to produce all of our visualizations. So starting here, we have our first dashboard. And this one covers 3 different visualizations that focus on the different days of the week and the traffic patterns there, as well as 4 different regions of Austin, Texas. So the first visualization on the left is a bar chart that shows the average speed for the different days of the week. This came out to show that Sunday had the highest speeds, with Friday having the lowest speeds. Then on the top right, we also broke it down by the total number of drivers for each of the different days of the week on the roads. And here we were able to see that Wednesday and Thursday had the lowest number of drivers there. And then finally, on the bottom right, we broke it down into a bar chart for the 3 different areas of the city in terms of the average speed. And here we found that the West had the speediest drivers, with the Central and Northeast coming out with some of the slower drivers. So overall, the metrics that we used here and focused on were average speed and that sum of the driver count. And we chose these metrics because we felt that they would be useful for company XYZ to kind of create some of these strategy plans in terms of logistics and creating routes. And we felt that focusing on the average speed as well as the amount of actual drivers were a good balance of these metrics to kind of see 2 different aspects of traffic patterns. And then the dimensions here, as I said, we focused on days of the week and regions of Austin to kind of make the connection between those 2 aspects of looking at different traffic aspects. And so for this dashboard, the primary audience is the company XYZ drivers that would be going on these routes and needing to consider looking at different areas of the city as well as days of the week. But then a secondary audience that could also benefit from this is just these employees as Austin residents that might be interested in the city traffic just for their own comings and goings. So now Haley's going to go through 2 other dashboards that we produced through Tableau.
Thank you, Jenny. And for the next 2 dashboard, we use an hour as a key dimension. As you can see, the first information we derive from the data set here is Austin, Texas tends to have the busiest road between 12 p.m. and 7 p.m. And this will provide logistics strategy team and drivers when deciding working hours. The drivers can start working when the traffic volume is low, and the company can deliver the products faster to the customers. And the next visualization shows we add additional dimension called geographic data using longitude and latitude. As certain points are having slower traffic no matter when, this can also be implemented when planning or deciding a new route. The strategy team can explore the dashboard clicking left and right button on the upper right corner and find out some spots such as the one with 30.26 and minus 97.96 are all colored in orange no matter when. And this will provide better transportation related decision in the future. And now Laura will go over the conclusion.
Yes, so we derived a lot of insights about the traffic trends and the fluctuations in Austin, Texas, and being able to visualize the busy hours and days and some of the cycles within the traffic will help company XYZ plan logistics and delivery, specifically accurately estimating delivery times and planning. They'll also be able to efficiently plan routes and schedules and maybe make changes to their current plans to help speed up delivery times. And things like this provide a lot of business value to any company in cost saving and in time saving contexts. So this data is not only beneficial to the company with which we're working, but also has benefits for the city overall. City officials and law enforcement can use this data for planning and for speedy response times and other things to help efficiency regarding to traffic in the city. Lastly, it's informative to the general public as they can use it to plan effective routes, when to or not to venture out, maybe plan alternative routes when going to work or going other places. And the direction data would be beneficial for someone perhaps moving to the city, not really knowing where to live and knowing which directions get the busiest. They can maybe plan where they're going to live on which side of their work so they can optimize their commute. So going through this whole process and finding out all these things, of course, we faced some challenges, especially with the large size of the data set. It took a couple attempts to try to figure out how to approach it. how to join things, which attributes to keep and not to keep, and what might be relevant. We also experienced a couple difficulties putting it into the cloud as well, and then again trying to join the databases together. I always think these were beneficial struggles though, because we got to experience handling real live data. You know, that you won't always be working with clean or simplified data. So we got to experience, you know, working through the process of trying to make it usable. We also got to integrate all the tools that we've learned in class and see all the concepts of data management that we've learned all put to action. And so with that, we thank you for your time and hope that you enjoyed our insights.